Welcome, Algebra, to Lesson 7.3, Angle Properties of Special Quadrilaterals, beginning on page 204 and going through page 208. Taking a look at page 204, you see a chart that lists all the angle properties of special quadrilaterals. The type of quadrilaterals we work with are parallelograms, rectangles, rhombuses, squares, and trapezoids, or as they say, trapezium. There are a total of 31 properties. If you look on the left, the two categories of properties that are important to the definition of these quadrilaterals are not necessarily something that you would use to define a reason why you would do a step in solving a problem, and that is the property of having one pair of parallel sides or two pairs of parallel sides. They are important, but they don't really play into proving what we are doing in our exercises. I will be giving you a copy of these charts. Now, if you are a person who learns best by looking at a chart and then reading the chart and then writing down the properties of the chart, or if you would prefer that they be arranged in a different way, all the properties arranged in a different way, please feel free to copy the chart. Otherwise, just add the photocopy to your other list of properties that we have covered so far in this chapter. Having said all of that, after you've looked it over a little bit, do pause and do that a minute. But we will now continue with try it 10 at the top of page 205. So looking at that figure, in the figure, PQRS is a parallelogram. PS equals 3x centimeters. QR equals 21 centimeters. QT equals 5y minus 10 centimeters. ST equals 3y plus 2 centimeters. Find the values of x and y. So if you look at x, that is a side of the parallelogram. SP and QR are both sides. And then the other two measurements where y plays a factor happens in the diagonal of the parallelogram, which is divided into two each side. So keeping all that in mind, we'll go through the steps. So try it 10. PS is equal to QR. So those two sides are equal because of the opposite sides of a parallelogram. Therefore, 3x is equal to 21. Solving for x, I come up with 7 centimeters for x. Pretty straightforward. Now, working with the diagonal, we find that ST is equal to QT because the diagonals of a parallelogram just kind of split in two there. Therefore, 3y plus 2 equals 5y minus 10. Now I'm just going to solve down to y. I want to keep everything positive, so I'm going to take my negative 10 and add 10 to each side, leaving me with 12. And then, of course, since I brought this over to this side, I have to take my y to the other by subtracting 3y from each side. So 12 equals 2y. And then I just flip it because I like my letters on the left. 2y equals 12. I solve for y equals 6 centimeters. So the math was pretty easy once we figured the setup. Continuing on with try it 11 at the top of page 206. If you look at that, in the figure, PQRS is a parallelogram. Find the measures of angles X and Y. So now with that diagonal PR through that parallelogram, we have two triangles, and we are to find both angles of the bottom triangle. Okay, so looking at that, I can say that angle X equals 110 degrees because of opposite angles in a parallelogram. Well, that was pretty easy. Moving on from there, now I know the three angles of that triangle. are going to total 180. So I'm going to set it up that way. 110 degrees plus 40 degrees plus the angle y is going to equal 180 degrees because of the sum, the angle sums of a triangle. I have 150 plus angle y is 180, therefore angle y is 30 degrees. Okay, that was pretty straightforward. Good deal. Hope they're all like that. Okay, bottom of the page, try it 12 comes next. In try it 12, it says in the figure, PQRS is a rectangle. Okay. Ooh, now I have right angles in the corners. Got to remember that. Find the measures of angles X and Y. Okay. I see lots of triangles in there. In fact, I can see 4 little triangles and 2 large triangles in various ways. Well, let's not make it too complicated. Let's just get right at it. In this, I can say that angle X plus 61 degrees is going to be 90 degrees because that's the corner of that triangle, of that angle. PQR is 90 degrees because it's the angle of a rectangle. So therefore, angle X is 29 degrees. Now, in triangle QRT, so that's the little one in there, QT equals RT because the diagonals of a rectangle. It means though that PT and ST are also equal. And they're all equal, all those little parts. Also in this same triangle, angle RQT is equal to angle QRT because they're base angles of an isosceles triangle. I know they're isosceles because that one angle is 61 degrees. If it were equilateral, it would have been 60, but it's not. So the base angles are each 61. Therefore, angle Y, I have to realize because of the property of vertical angles, angle Y equals QTR. I didn't list that property, I probably should have. Now, I can say that that would equal angle Y would then equal 180 minus 2 of the base angles. 180 minus 2 times 61 is 180 minus 122. Therefore, angle Y is 58 degrees. Okay, took a little more thinking, but doable. Continuing on to the next page with try it number 13. It says in the figure, PQRS is a rhombus. Find the measure of angle X and the measure of angle Y. I notice the 4 sides are equal. I notice one of those angles of the 2 triangles that make up the rhombus is 65 degrees. So we are not working with equilateral triangles. We are working with isosceles because of the equal sides. Just keeping all that in mind. Therefore, I can simply say angle Y is equal to 65 degrees because of alternate angles. Doesn't matter that I start with Y first. I just do the most obvious one first. And therefore, angle X is going to be 180 degrees minus 2 of the base angles, which are 65 degrees apiece. Sum of the angles of a triangle. And so I got 180 minus 130. X is 50 degrees. Angle X is 50 degrees. Okay, that was easier than expected. We have one more to go, I do believe, at the top of page 206. Try it 14. Try it 14. Let me get all the way in here. There, I think I'm there. Okay, so try it 14. It says in the figure, ABCD is a square. So equal sides, 90-degree angles in the corner. It also says triangle ABE is equilateral. Find the measure of angle AED, which is the base angle of the triangle next to that equilateral triangle. So I'm dealing with an isosceles triangle in that particular case because it told me different things, I'm guessing. So I got to go about proving all this. So this is where we got to do a lot of proving to get to our answer. So let's start with angle EAB is going to be 60 degrees because of the angles of an equilateral triangle. And then the angle of BAD is 90 degrees because of the angle of a square. Therefore, angle EAD is going to be 90 minus 60, which is 30 degrees. Okay. Now, since AE is equal to AB because of the sides of an equilateral triangle, and AB is equal to AD because of the sides of the square, we have AE equal to AD because they're all equal. Okay, therefore, angle AED is going to be equal to angle ADE because they are the base angles of an isosceles triangle, just like we kind of guessed at the beginning. Therefore, I can use that 30 degrees, and which is the top part of that isosceles triangle. Therefore, 180 minus 30 is going to give me the total, which is 150, the total of the two base angles. So I'm going to divide them by 2. So 180 minus 30 divided by 2 is 150 divided by 2 is 75 degrees. Therefore, angle X is 75 degrees. And there you have it. As always, you can pause, rewind, rewatch, ask questions, get your notes all lined up before you start doing things. It really is important to know what you're looking at when you do the work in this exercise over the next 2 days. I believe our assignment is on page 208 and 209. I think we go 1 through 4, but I can double check that tomorrow before I set you loose to do it. I will double check that. I'm thinking it's 1 through 4. Okay, thank you. Do good math.